9.2 example 3 is a really good question where it wants us to match each graph to the corresponding equation. And they give us, equation A, B, C, and then graph 1, 2, 3. They also want us to give, to justify this, to give some kind of reason. They'll just, and don't just put it into your calculator. You're not going to learn anything doing that. What we're going to do is we're going to approach this with the same technique we used with the other questions. So for a of x, I'm going to immediately factor it. So that's x times x plus 2. The denominator is the difference of squares, so it's x minus 2 times x plus 2, and we'll just kind of leave that for now. We'll factor all of them here relatively quickly. B of x, I can factor a 2 out of the numerator, which leaves me with x plus 2. And although a lot of students get frustrated by this, there is no sum of squares. So I cannot change or factor x squared plus 1 at all. I have to leave it that way. And then the last one, c of x, there's not a big advantage to doing this, but I always like writing that as 2 times x. And then the denominator, again, difference of squares, so it'll be x minus 2 times x plus 2. And although we could certainly at this point maybe match one of the graphs based on what we have, I'd like to go through some of the detail that we're doing in this chapter. So if I look at function A, so the first graph I'm looking at, I know that it has an x-intercept at 0, 0. Now you should be asking yourself, or maybe recognizing why that is, and it's because the factor x is only in the numerator. X plus 2 does not yield an x-intercept because it's in the numerator and the denominator, which is my next point, that this guy has a point to discontinuity at, and I am just going to put x equals -2. Remember, it's whatever makes the factor equal to 0, which is your point to discontinuity or your vertical asymptote. And then speaking of vertical asymptotes, this graph does have one. The vertical asymptote for this guy is that x equals +2 because x minus 2 is only in the denominator. All right, now before we match the graph, I'm going to do b of x and c of x as well. B of x has an x-intercept. That's going to be at -2, 0. Is there a factor present in the numerator and the denominator? No. Is there a factor present in just the denominator? Or sorry, yeah, just the denominator. There is. Now, that means that a vertical asymptote would occur when x squared plus 1 is equal to 0, which is a bit of a problem because what we get, oops, I put that in the wrong place, is when I move the 1 over, I get that x squared is equal to -1. Well, that means that x could be the positive negative root of -1. Does that exist? And it doesn't. So what that means is that there are no vertical asymptotes for that graph, right? There is no value of x that causes us to divide by 0. There's no factors in the numerator and the denominator, so there's no points of discontinuities as well. For c of x, we have an x-intercept at 0, 0. We have no points of discontinuities because there is no factor that's present in the numerator and the denominator. And then my vertical asymptotes are going to be at x equals 2 and x equals -2 because both those factors are only in the denominator. Now that's a lot altogether, but this is what chapter 9 is about. There's one more thing that I could do if I wanted to, and it's not a bad idea, which is the y-intercept. Now keep in mind for the y-intercept, I'm making x 0. Well, if x is 0, then the numerator is 0, the entire thing is 0. That's the nice thing about the origin. It is both an x-intercept and a y-intercept. For my red function, if I wanted to find my y-intercept, I would put 0 in for x. So that's going to be 2 times 2, which is 4, divided by 1. My y-intercept is at 0, 4. On my blue function, again, it goes through the origin. So we could just skip and say that my y-intercept is at the origin as well. Now, that's beneficial because really what we're going to do is we're going to use this, table of information and try to look for kind of unique information. And the biggest one that jumps out at me is that this red graph is the only graph that has an x-intercept at -2. So what I could do is I could go up to my graphs and look for the only function that has an x-intercept at -2, and we see that it's this one right here. So this is the graph of b of x, graph 3. It's the only curve that has the x-intercept at -2, 0. Now, there's certainly other, information we could use. That graph doesn't have a vertical asymptote, and it doesn't have a point of discontinuity. And that's really, kind of useful for us to determine that. All right, let's go back to our information here. I know I'm scrolling a little bit in this lesson. Point of discontinuity. Only one of these graphs has one, and only one of the functions we would expect one. So when we look at graph 2 is a of x. And again, the best way of telling that is there's my point of discontinuity right there. We could maybe use the y value to confirm. There's other ways of checking. The vertical asymptote is at +2, that works. The y-intercept and x-intercept are at the origin, that works as well. So a couple little things that kind of reinforce the logic leaps that we're making. All right, then, process of elimination, graph one should be C of X. And we can take a look. I'm just going to kind of, X-intercept and Y-intercept are at the origin. We have a vertical asymptote, at positive 2, one at negative 2. And again, the Y-intercept is at the origin as well. So that makes sense that that would be C of X. Really interesting question because it's pushing the whole process all at once, and analyzing these rational functions is not the simplest thing, but it is nice because it's always going to go back, and I'm going to put it up here because it's actually in your textbook, this right here. A factor only in the numerator corresponds to an x-intercept, only the denominator is a vertical asymptote, and in both is a point of discontinuity. Now, I am going to include an extra video in chapter 9 here. I'll put up the assignment, but please make sure you do watch the 9.2 horizontal asymptotes video as well, because the textbook doesn't really cover it very well, and I wanted to include just an extra bit to make sure you understood where they get their answers from in the textbook.